So I just realized that I had my door closed while I was doing this, and this ran over through my office hours from 11 to 12. So if you came by and the door was closed with that do not disturb sign, I'm really sorry that I missed you during my office hours. So when I did this test, what took me a long time was drawing this picture I'm about to paste in. I drew this thing 2 or 3 times and I erased it, and in the recording you only see the final drawings. And so to explain what's going on, so I actually ended up solving it in my head without the drawing, proper drawing. So when it's uncompressed, you push it down to the starting point. It says that you compress it down 150 millimeters or 0.15 meters. And so at any point x, so here's the datum, and so this distance is x, but the amount the spring is compressed, okay, is this, delta x. Okay, and I drew this weird on the real-time solution, but I knew that this is what I wanted to do in my head. And so delta x, the amount that it's compressed, is the amount you pushed it down minus how much came back, so 0.515. And it's just because we're measuring x from the bottom where it's squished down. And the force in the spring, of course, is k times delta x, and that was a typo. It was supposed to be 1750 newtons per meter, and so that's what I put in. And so that would just come out to 1750, 0.15 minus x. Okay, and that actually comes out to quite a large number, 1750 times 0.15. And continuing on, I then drew the free body diagram, which was actually pretty simple. There's the weight. There is this force in the spring, which is 1750, 0.15 minus x, and that will equal the acceleration going up. And so there's only one component, and so you get minus mg plus 1750, 0.15 minus x equals ma, and that just made a was 1750 times 0.15 minus x all over the mass minus g, and then I just plugged in the numbers and I got 121.44 minus 875 x. Let me write that in. Okay, and then I noticed a was a function of x. I immediately went to a dx equals v dv. I integrated that from 0 to 0.15, 1750, 0.15. Oh no, I put in a simplified version, sorry. I put in 121.44 minus 875x dx equals integral from 0 starts at rest to the final velocity v dv, which is just 1/2 v squared. And so this just came out to 121.44 x minus 875 over 2x squared from 0 to 0.15 equals 1/2 v squared, and I just solved for v. And I got 4.09 meters per second up, meters per second, so 4.09 meters per second up. So I just checked my fast solution. I got that wrong again. What happened was when I forgot to divide this side. I missed a 2 somewhere, and I think I did it in the class as well when I went over it. I was going too fast. So basically, um, I went through the algebra of this thing too fast. Sorry for that. I don't know. I'd probably, I'll take 3 to 5 points off for that error because it propagated. So yeah, maybe 5 points off. So yeah, there went my A plus.